Social Studies, Unit 1. For the next few weeks, we will be studying the theme of physical geography. This theme focuses on the world around us and its features. During our social studies lessons, we will learn about physical features like oceans, mountains, and islands. We will learn how to use all of the important parts of an atlas to create our own maps, and even learn how to locate areas on the Earth's surface using longitude and latitude. Parents can help their students improve their knowledge of maps and physical geography by taking time to show students road maps before you go somewhere in the car, and getting onto GoogleEarth.com to locate your home. What is geography? Well, that's a great question. Geography comes from the prefix geo, which is Greek for the earth. And graphy just means a description or the study of. So when you put these together, geography means the field of study that enables us to find answers to questions about the world around us. It's basically the study of the earth. This is a very famous photograph. It was taken decades ago by astronauts who landed on the surface of the moon. And you can see here at the bottom, this is actually the lunar surface. This is the ground on the surface of the moon. And when astronauts landed there, they looked up into the night sky and they saw what looked like a blue marble shining in the sky. And they realized that this was their home, the Earth, and that the sun was shining down kind of on the upper half of the Earth and was reflecting back, and this is what the Earth looks like from the moon. Now, this is a pretty awesome picture on its own. But when the astronauts came back and they shared this photograph with the rest of the world, it made people think. And it made them realize, with all of our history on this planet, humans have lived and died. They have discovered things. They've written symphonies, created amazing works of art, solved global problems, but there also has been conflicts, battles, and wars. There have been times in history when diseases have wiped out millions of people on the planet, and there have been natural disasters like volcanoes or hurricanes. And when people saw this picture of the Earth from space, it made them realize that we only have one home. We only have one Earth that we all share together. You can see from this photograph that you can't identify countries or states. You can't see people's beliefs. You can't see people's religions. You can't see any of these things. You just see this shiny blue planet in space. And it made people realize that we only have one world, and it's going to take all of us to work together to protect this fragile blue marble. And that's why this photograph is famous.
Humans have been studying and writing about Earth for thousands of years. Answering questions such as, where are things located and why are they there, is the practice of geography. Geographers are scientists who study Earth and its people. They set out to gather information and then use it to make connections between places, processes, and human activities on Earth. Many civilizations have used maps as a tool for writing about Earth. Just like today, maps helped ancient peoples define their place in the world. For example, the ancient Babylonians put themselves in the center of the world in this map from about 600 BC. In the 1970s, the United States Department of Defense developed the Global Positioning System, or GPS. GPS allows people on land, at sea, or in the air to find their exact location or to track moving objects in any weather. A network of 24 orbiting satellites sends GPS information to receivers on Earth. More than 2,000 years ago, Polynesian sailors were among the first people to sail the Pacific Ocean. But they did not have charts or instruments to help them find their way. So these ancient navigators made sea charts from palm sticks that they tied together with coconut threads. The small shells represent islands. Some geographers focus their study on the planet and are known as physical geographers. They might create maps or study the weather. Other geographers trace the movement of people and how they interact with the planet. They are known as human geographers. Human geographers might interview people to learn more about their lives. An artificial satellite is a device sent into space, where it orbits Earth. Satellites gather information that helps map makers, historians, and archaeologists. This is an image of Earth taken by a satellite. Geographers use such images to make accurate maps. Some satellites scan infrared waves from Earth. These images help archaeologists locate sites for future digs. They also help historians learn how past humans changed their environments and where natural disasters took place.
Soon, you'll be learning about maps, which are pretty good, but they aren't the best, and this is why.
Look at this map. It's probably similar to the one you had growing up as a kid. Now, would it shock you to learn that California is twice the size of Portugal? That Greenland could fit inside the African continent more than 14 times? Or that Australia is larger than the entire continent of Europe? I hate to be the one to break it to you, but this map has been lying to you your entire life. The problem lies in projection, which in mapmaking terms means the impossible task of accurately representing a 3D object, such as our spherical planet, in a two-dimensional map. It's a problem that's plagued cartographers for centuries, and even made an appearance on the West Wing.
Are you saying the map is wrong?
Oh dear, yes.
For example, that map from earlier, the one you grew up with, this is the man responsible for your literally distorted worldview. Gerardus Mercator was a Flemish cartographer, and in 1569 he created the Mercator projection. This map, which is still used today, found favour and was quickly adopted by the rest of the world because it preserved local angular relationships. Those are these straight lines here. Those straight lines make seafaring navigation so much easier. However, the downfall of this projection is that the closer the landmass is to the top poles, the more distorted it is. Although the shapes of these countries and continents may be correct, it's their relative size that leaves a lot to be desired. You're able to fit the entirety of the United States, India, and much of Europe inside the outline of the African continent. But the distortions don't end there. According to the Mercator projection, Russia appears to dwarf the US, but in reality, Russia is only 2 times larger. Canada is the same, only being 1.2 times larger than the US. One of the most common alternatives to the Mercator projection was presented in 1974 by this man, D. Arno Peters. The Gall-Peters projection makes seeing relative size of places much easier.
We'd like President Bartlett to aggressively support legislation that would make it mandatory for every public school in America to teach geography using the Peters projection map instead of the traditional Mercator.
Give me $200 and it's done.
However, to do this, it has to sacrifice the shape of the countries. Certain places appear stretched, horizontally near the poles and vertically near the equator. The fact is that there is no perfect map for all occasions. We've come to believe that this is our best option, but that logic was based in a time where seafaring was at its height. We've changed our maps before, as we've come to learn more about the world. When the Mercator projection was first incepted, this was our idea of America. Perhaps with the advent of satellite imagery, it's time to shift our worldview once again.
All right, here we go. If I want to turn this globe into a flat map, I'm gonna have to cut it open. In order to get this globe to look anything close to a rectangle lying flat, I've had to cut it in several places. I've had to stretch it so that the countries are starting to look all wonky. And even still, it's almost impossible to get it to lay flat. And that right there is the eternal dilemma of map makers. The surface of a sphere cannot be represented as a plane without some form of distortion. That was mathematically proved by this guy a long time ago. Since around the 1500s, mathematicians have set about creating algorithms that would translate the globe into something flat. And to do this, they use a process called projection. Popular rectangular maps use a cylindrical projection. Imagine putting a theoretical cylinder over the globe and projecting each of the points of the sphere onto the cylinder surface. Unroll the cylinder and you have a flat rectangular map. But you could also project the globe onto other objects, and the math used by map makers to project the globe will affect the way the map looks once it's all flattened out. And here's the big problem. Every one of these projections comes with trade-offs in shape, distance, direction, and land area. Certain map projections can either be misleading or very helpful depending on what you're using them for. Here's an example. This map is called the Mercator projection. If you're American, you probably studied this map in school. It's also the projection that Google Maps uses. The Mercator projection is popular for a couple of reasons. First, it generally preserves the shape of countries. Brazil on the globe has the same shape as Brazil on the Mercator projection. But the original purpose of the Mercator projection was navigation. It preserves direction, which is a big deal if you're trying to navigate the ocean with only a compass. It was designed so that a line drawn between 2 points on the map would provide the exact angle to follow on a compass to travel between those 2 points. If we go back to the globe, you can see that this line is not the shortest route, but at least it provides a simple, reliable way to navigate across the ocean. Gerardus Mercator, who created the projection in the 16th century, was able to preserve direction by varying the distance between the latitude lines, and also making them straight, creating a grid of right angles. But that created some other problems. Where the Mercator fails is its representation of size. Look at the size of Africa as compared to Greenland. On the Mercator map, they look about the same size. But if you look at a globe for Greenland's true size, you'll see that it's way smaller than Africa. By a factor of 14, in fact. If we put a bunch of dots onto the globe that are all the same size, and then project that onto the Mercator map, we will end up with this. The circles retain their round shape, but are enlarged as they get closer to the poles. One modern critique of this is that the distortion perpetuates imperialist attitude of European domination over the southern hemisphere.
The Mercator projection has fostered European imperialist attitudes for centuries and created an ethnic bias against the Third World.
Really?
So if you want to see a map that more accurately displays land area, you can use the Gall-Peters projection. This is called an equal area map. Look at Greenland and Africa now. The size comparison is accurate, much better than the Mercator. But it's obvious now that the country shapes are totally distorted. Here are those dots again so that we can see how the projection preserves area while totally distorting shape. Something happened in the late 60s that would change the whole purpose of mapping and the way that we think about projections. Satellites orbiting our planet started sending location and navigation data to little receiver units all around the world.
Today, orbiting satellites of the Navy Navigation Satellite System provide round-the-clock, ultra-precise position fixes from space to units everywhere in any kind of weather.
This global positioning system wiped out the need for paper maps as a means of navigating both the sea and the sky. Map projection choices became less about navigational imperatives and more about aesthetic, design, and presentation. The Mercator projection, that once vital tool of pre-GPS navigation, was shunned by cartographers who now saw it as misleading. But even still, most web mapping tools like Google Maps use the Mercator. This is because the Mercator's ability to preserve shape and angles makes close-up views of cities more accurate. A 90-degree left turn on the map is a 90-degree left turn on the street that you're driving down. The distortion is minimal when you're close up. But on a world map scale, cartographers rarely use the Mercator. Most modern cartographers have settled on a variety of non-rectangular projections that split the difference between distorting either size or shape. In 1998, the National Geographic Society adopted the Winkel triple projection because of its pleasant balance between size and shape accuracy. But the fact remains that there's no right projection. Cartographers and mathematicians have created a huge library of available projections, each with a new perspective on the planet, and each useful for a different task. The best way to see the Earth is to look at a globe. But as long as we use flat maps, we'll have to deal with the trade-offs of projections. And just remember, there's no right answer.